Okay, welcome to this Python presentation talking all about strings and how we slice them and dice them, chop them up in Python programming. So, like all good presentations, let's start with a joke. String walks into a bar with a few friends and orders a beer, and the bartender says, "I'm sorry, we don't serve strings here." String goes back to his table, ties himself in a loop, messes his hair up a bit on the top, and walks back up to the bar and has another go at ordering a beer. And the bartender squints at him and says, "Hey, aren't you String?" To which the String replies, "Ha, I'm afraid not." Well, there you go. That's Python humour or string humour out the way. So, on with strings. Well, we've been looking at strings since really the start of the Python course. Strings are one of our types of data that we can store. So if we say something like month equals April, as we've done in here, April's in quotes, so April's a string, so month is now a string variable. And we know we've stored the string April somewhere in memory, and we know that month is actually a pointer or a reference to where we store the letters A, P, R, I, L somewhere in memory. And we know that to actually store the word April, we store the ASCII values of each of those letters somewhere in memory. Pretty straightforward. Well, obviously those memory locations to store a string are sequential somewhere. Not quite as straightforward as this, but in principle we're all on the right lines. So 5 sequential memory locations are allocated, and they store the ASCII codes for A, P, R, I, L in there. A month, the reference actually points to the first letter of the string, and there's a way that we know the length or the end of the string that we're not going to go into, but suffice to say that month points to the start of the string and the letters are stored sequentially. So with that in mind, what does that kind of indicate that we might be able to do within Python? Well, it means that if we've got these letters stored sequentially in memory, surely we can go and get access to a particular letter out of the string rather than having to pull the whole string out in one go. If we use the variable month, then we'll get the whole string. But if we use this syntax with square brackets, month brackets 0 or brackets 1 or brackets 4 or whatever, that tells me the position in the string of the letter that I want. Now, all strings start where the first position is 0. We think it makes sense for it to be 0 because it's a 0 offset from where the label points. The label for month points to the first letter, so 0 offset from there is the first letter. That's why it's position 0 and not position 1. So it catches a lot of people out that. So the first position is 0, that's where the A is stored, the P is stored in position 1, and it's 5 characters long, A, P, R, I, L, but obviously the L therefore is in position 4, and there's nothing in position 5. So if we want to access a letter within our string, we can just say the name of the variable, put square brackets, and put an index value there. The index value picks out the particular letter at that index position, again starting at 0. So pretty straightforward. Well, can we do more than that? Can we slice up a string? So slicing up a string, imagine going in there with your sushi knife now and chopping this string up and taking sections of it out depending upon what you want. So here we've got a string throught. Obviously it's got a space in there, you can see it, character position 2, index position 2. We've got the a space, ASCII value for that is obviously stored. And if we want a sequence of letters, then we use the colon notation. So place colon 0, 1 means from position 0, which is S, up to but not including position 1. So position 1 is the T, so it's not including that. So in fact, place 0 colon 1 only gets out the first letter S. If I'd wanted to get the S and the T out, I would have had to say 0 colon 2. Because it would have been from 0 up to, but not including the 2, which would have been 0, 1. That would have got me the ST. So I can do that. I can also go to the end of the string without having to worry about where it is. Because obviously, throught here, I'd have to kind of figure out how long it was and worry where the end was at position 7 if I wanted to go all the way to the end. There's a neat way to go all the way to the end, just using a colon and leave the figure on the right of that blank, and that means to the end. So if we look at place 3 colon blank, that means to the end, and it means the very end, including the last character this time. So obviously position 3 is a capital N for Niets, and the colon blank is all the way to the end, so that would extract the word Niets out for us. And that's called slicing a string. We can pull out bits of the string from anywhere within it and the individual characters and so on. Okay, how would we actually get the last letter of a string? So here we are, we're going to set Niets, and I just want to, wherever the last letter is, I want to get that. And obviously I have to look at set Niets and measure the length of it. Now if you count carefully, you'll see it goes 0 to 7, so it's actually 8 characters long. So the last character is not at the length of the string, but at 1 less than the length. So for any given word of 10 characters, the last character will always be just 1 less than that at character position 9, because we start at character position 0. So if I wanted to get the last letter out, what would I have to do? I'd use a len function on the variable place, which would return me a value of 8, and then I'd do place square brackets word len minus 1, which would be 8 minus 1, so that would get me a 7, and that would get me the S that's at set Niets. So that's how I can extract a letter from the end. Now it's a bit of a pain to do that, and again the people who wrote Python thought, well, you know what, we don't always want to do that. It's quite often we just want to start at the end of the string and count backwards. So they've introduced the concept of negative indices. A negative indices starts at the end of the string and counts backwards, and the last character of a string is always -1. It obviously can't be 0 because that's the first character. So the last character of a string is always -1. It means we can use that without worrying about how long the string is. So obviously the T at the end of the string is at position -2. Or you could figure out how long the string was and use the index value 6. They both point to that same individual letter T. If we wanted to do from -3 to the end, what would that do? So we count backwards from the end. -1 is S, -2 is T, -3 is the O. So from -3 colon means to the end, and that would get me the OTS. So I can pick out the end of a particular string. Now it might just seem like we're creating these slicing things because we can, and what's the point of it? If you think about things that we do in programming and handling information in programming, we're quite often interested in the last 3 letters of a string. If you can have a quick think where in programming you might have come across the last 3 letters of a string being quite important, and if you think about it long and hard enough, hopefully you'll come up with file names, because file names have got a dot extension and then usually 3 letters at the end to tell you what type of file it is. So this would be an example using -3 colon of where we could extract the end of a file name, and from that we'd know what type of file it was, so we'd know what to do with it. So there are practical uses for these, honestly, all along the way. So let's give those a go. Let's just try those in a bit of Python to see what actually happens. So we can create a name, and I'm going to create a fictitious name, Fred Blogs, infamous Fred Blogs. And if I do name brackets, well, let's just do name first of all. Now, those of you who haven't played with this, you might not have realized we're in the command line interface at the moment, so to actually print something, I don't have to use the word print. If I just put the name of the variable here, it will print it, because I'm not running a script, I'm actually typing it straight into the command line. So if I do name square brackets 0, what do you think I'll get there? Obviously I'll get the F, which is the F from the Fred. If I do name square brackets 0 colon 3, what will I get from there? 0 is Fred, 1 is R, 0 is F, 1 is R, 2 is E, and 3 is D. So I'll get F-E-R-E-D. Will I? No. I'll only get the F, R, and E. Remember, this means up to, but not including the 3. If I want to get the end of the string, then I would just do name square brackets -1, and that should get me the S, which is at the end of blogs. And if I want to just get the surname, which I know is 6 characters long, I would just do name -6 colon, so that's from 6 in from the end to the end, and that just gets me the name blogs out. So that's showing you how we can kind of slice up strings, get individual characters out, and mess around with strings. So hopefully you've got an idea now about how we index strings, we get out an individual letter in the string, and how we can slice up a string to get another area out of it. Just if I just finish off just creating a variable length to be the len of name, and just get length. You can see length was 11 because it's 11 characters long. So just to again confirm that the last character was actually at 10, if I do name 10 because it's 11 -1, there again, that's the S at the end of blogs. Okay, great. Hopefully you've got that idea. So on with the presentation. Okay, so that worked quite well. We've given that a go. Hopefully quite happy with it. So what next? Well, we often want to go through a string, selecting one letter at a time sequentially, starting from the beginning of the string to the end of the string. So obviously we just print the string out, it'll just print it out horizontally across the line. What happens if we want to print it out one letter at a time? Well, obviously we are going to use some loop function because we're going to go around the loop several times. If you think about what we've talked about with the index, it would make sense if the index starts at 0, then I could presumably have a variable that starts at 0, and each time we go around the loop that variable is going to increase by 1, and I'm going to use that variable to point to increasing positions within the string. Kind of makes sense. So let's have a look how we do that. Well, here you go, we've got the word superb. Obviously it could be any word, so one of the first things we need to do is to work out the length of the word. So we've now used the len function on word, and the word length in this case would tell me it's 6 characters long. And we want to go round a loop starting at 0, going up to a fixed value, which in this case is word length. And what do we need? Well, obviously a for loop. So we've now got for index in range 0 to word length. So just going through what all these terms are. Well, our index is our loop variable. So this is a variable that's going to take on the value 0 initially, and each time around the loop it will go up by 1 until it gets to the value word length, although obviously it never actually gets to that one, it'll stop one before it. We'll have to have a think about how that works in a minute. So index is our loop variable, in is part of our construction, range is because I want the range of numbers from 0 up to the word length. So this is our what we call our iterative list, because we can go through this one number at a time. Okay, so what do we want to do within our loop? Well, within our loop we want to print index and then the value of index, just so we can actually see it count up. And then we want to print the letter, or the text letter, and then we're going to do word brackets index. So this is going to be picking out individual letters from the word. The first time around the loop, index will be 0, so it should pick out word brackets 0, which is a capital S. The next time around the loop it should be a 1, so it should print out the U, and so on. And if we think about it, our word is 6 characters long, so the index values are 0, 1, 2, 3, 4, 5. So we don't actually want the loop to go up to 6 anyway, we only want it to go up to 5, which fortunately is exactly what a for loop does. It doesn't go to that last value. And in fact, this is one of the reasons for loops don't go to that last value, because we often start loops with 0, which is one less than the count. Okay, so hopefully that kind of makes sense. The terminology we use around this is we say we're iterating through the word. Iterating means counting one or counting in units, maybe ones or twos, some common number at a time, starting at one end and heading towards the other end. And we iterate through things quite often in Python. So we say we're iterating through this. And the good thing about doing it with this method, using a for loop and an index value, is we know at any point in our loop exactly where we are. The index value tells me that I'm at position 4 or position 6 or 10 or whatever, and I've got this letter at that position. So if I'm very interested in the position of a letter within a word, then I would always be using this technique to loop around that word and get it out one letter at a time. So let's have a look at kind of seeing that in action. Let's go back to our bit of code. Now I'm actually going to write it as a program this time because I'm more likely to make a mistake. It's got some random temp here. Let's get rid of that. This is something I was doing before. So I'm just going to do what I did there. So I had word, which was superb, and I did length as len word, and I used my for loop. So there's my for loop from 0 up to the length of the word, and I want to print out, well, I want to actually see the index value just so I can kind of visualize what's going on with that. I don't actually need it, but it's just going to help me understanding what's going on. And then I want the word letter, because that's what I'm pulling out of the word, and I have word square brackets index. Okay, so let's just run that program. And there we go. What we got at the end of that? We've got 0 at position 0, the letter S, position 1, the letter U, 2, P, E, R, B, all at 5. Would it have worked for anything else? Superman is my hero. Okay, so it's a much longer string. Run that. There we go. Superman is my hero. So it'll work for any string, obviously, because we measured the length. So hopefully that gets you the idea about how we iterate through a string, pulling out one letter at a time for whatever reason we want to do that. Okay. Okay, so that was how we iterated through the list using the index value. It was pretty straightforward, really. But it was a bit of a pain because we had to calculate the length of the word before we could do it. And we've had to create a for loop and this index. And maybe we didn't want the index, we just wanted the letters one at a time. And I didn't really care where they were. Well, Python has got a really, really neat way of iterating through lists where we don't use the index value. And it takes care of all that for you and where the end of the word is. And this is the way we do it without using its position. Syntax is very similar to what we've looked at. Here's our word superb again. You'll notice now we don't calculate its length, but we have this syntax here, for letter in word. Now, it might seem a bit foreign to start with. It's not what you've seen before, and it kind of, you think, oh my goodness, this is some super special case. It's not. It's just a for loop. It's a for loop like we've seen before. But Python is very clever, and when we use for loops like this, this is what happens. So the for loop is for, and then the first thing in the for loop is always our loop variable. So this loop variable will take on the initial value at the start of the loop, and then it will go all the way through one at a time until it gets the end of the loop. And then we have the in command, which we've had before, and then normally we have range, where we specify a range of values, and we do things like 0 to 10. So if you think what range 0 to 10 produces, range 0 to 10 produces a list of numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, never gets to 10. It's just a sequence of numbers. Well, what's word? word is a string. It's just a sequence of letters. So what this incredibly cleverly does in Python is it assigns the variable letter to the first letter in Word and runs a loop. It then assigns the letter to the second letter in Word and runs a loop, and then to the third letter and runs a loop, and goes all the way on to the last letter and runs a loop. So we don't have to use the index to go in. This will do it automatically for us. And we just now print the letter. Notice we don't know where the letter is within the string when we're actually in that loop, because we've got no index value, we've no counter keeping track of where we are. But depending on what we want to do, that might be sufficient. We might not need to know where we are, we just want the letters out one letter at a time. And again, we say here we're iterating through the word, and we say that word, i.e. a string variable, is iterable. That means we can go through it one letter at a time. And obviously you can see the syntax there is easier than the previous version, because I've not had to calculate the length of the word, and I've not had to include this extra variable index to worry about where I am. So just to see that one in action, let's get it back up. So here we go, we'll do it with this one that we've had before. So I don't need to worry about the length anymore. It would be wrong to call it index now, because it's not an index value, so I'm going to call it character. So I'm picking out a character, and it's a character being picked out of the string word. And what do I actually want to print this time? I want to print the letter, and then my loop variable was character. That's printing out one character at a time. So let's just run that. There we go. Letter Superman is my hero, and we're picking out one letter at a time. But you can see, as we just discussed, we've obviously lost the index, so we don't know when we're printing out this I where it is within the string. We just know it came after that space, and when we look, the next one's an S. Where it is in the string, it is lost to me. But again, that might be all that we need. Okay, so that's a different way to iterate through strings. So that's really good. So what we want to do now is think about how that's going to be useful for us in the context of writing this Hangman game. If you've been picking up bits about the Hangman game, the part that we're interested in now is the bit where we know the words, obviously, that the user is trying to guess. So we've got a word reality here. The user has suggested there might be an A in there, and our program has to go and look at the word reality in this case and see if there is an A in the word reality, and if there is an A in it, obviously return the position of it, so we know that he's found the letter at position, in this case position 2, because R's at 0, E's at 1, so our A is 2. So we need to write the code that will actually do this for our Hangman function. Okay, so we'll do it with this bit of code here. So we'll have our reality, and we'll actually put it in a function this time. So def find character, and we obviously want to find the character in the word, and we need to know what character we're looking for. So we'll look for a particular letter. So we're going to define a function like that. What we're going to do within our loop, well, we're going to go through our word one letter at a time. So, and I do need to know the position, so I'm going to go back for the index root this time. So for index in range 0, len word. Now you can see here I've not created a separate variable this time. That's just kind of a quick neat way of doing it. So the length of the word here will come in, be calculated, and I'm going from 0 up to that length, so that will work. I've not spelled character right there, to improve that. And at the moment what I'm going to do is, just to check that my function and everything is working, I'm just going to print word square brackets index. So just to check that I've not made any mistakes in my function as I set this up. So we need to set up our word in main. So we do a define main there. And we've got our word reality, and the letter we're looking for is an A. So I've got the word reality, the letter's looking, and what I need to do is I need to call the function find character. And I'm giving it the word, which in this case is reality, and I'm passing in the letter, which in this case is A. They go into the function, into variables which happen to be the same name, word and letter. And we're just at the moment, we're not actually worrying about the letter, we're just going to see if this works. And we're just going to print the letters one at a time. So it should just print reality for us. Let's just make sure that works. Okay, it didn't work. Why did it not work? Because I forgot to call main. Schoolboy error there. Okay, so reality. So that seems to be working now. So coming back to my main bit of code here now, knowing that this word brackets index is looking at each letter in turn, what do I want to do? Well, obviously I'm trying to check if that particular letter, so that's word square brackets index, is indeed the letter I'm looking for. So simple if statement, comparing word brackets index with the letter that I'm looking for, and if the two are the same, I've obviously found it. So what do I want to do? I want to break out of my loop. So I need to break out of the loop like so, and if I've broken out of loop, what do I then want to do? Well, obviously back here then, having broken out of the loop, I need to return that value of index, because that's the position where I found my letter. So where will this value of index go? It goes to where the function was called from, which is this find character. So when the function finishes and we return back to here, that value is passed back to this point in the code. So we need to assign that to a new variable called position, because that's where we found our particular character. And I've already edited the code here. What do we want to do now? Print letter found at position, and obviously we're going to put position in there. So let's run that now and see if that works. Hooray, REA, and you can see the loop ended at this point because it found A at position 2. It exited from our function, exited from the loop out of the function, and returned position 2. So we found it. Is that in the correct position? Yes, because R is 0, E is 1, and A is 2. Let's see if we can find another letter. Let's see if we can find the Y at the end of our string. There we go, reality. It got to the last letter and it exited, broke out, and found the Y at position 6. Brilliant. So we've basically iterated through our list here. We've been looking for a particular letter. When we find it, we break out the loop, return the index value at where we found it. That's returned back into our main code, put into the variable position, and hey presto, now we've got the position of where we broke out of the the letter was stored in the actual word. Fantastic. That's going to be really useful for our Hangman program. Great, so we've done part 1 of our Hangman function. Having found the letter, what do we do next with the letter? So we now need to understand a little bit more about Python. So what we now want to do is we want to try and change the letter in a string. So here you go, we've got a string, it's got St. Neots, which is a place down Cambridge way, and I want to change it to St. Piet's, which is a place that I don't think exists, but I want to change that capital N to a capital P. So knowing that we can access this letter with place square brackets 3, one would assume that I can change the letter with place square brackets 3 equals P, because I just want to swap this letter out. So if you were to try that in Python, you'd find that it doesn't actually work. It doesn't work because place is a string variable, and strings are immutable and we can't change them. So by all means give it a go, but you'll find it won't work. So, well, it's a reasonable thing to do. We need to be able to change letters within strings. So how do we actually do it? Well, we've got some ideas already from what we've talked about. What we need to do is we need to slice up the string and build a new string around that letter that we want to change. So basically we take the letters from the start of the string up to the letter that we're interested in. So you can see we've got 0 to 3 here. 3 is where our n is. So we know that actually only takes 0 to 2. So that will take the st and the space. So I've sliced out the start of the string up to the letter I'm interested in. Ignore the letter at the moment because I'm going to change that. And I want to get all the letters after the string. So our n was at 3. So we go from 1 beyond there, which is 4 colon blank, which is to the end of the string, and we get the eats out. So we can get the letters before the letter I want to change, and we can get the letters after the letter that I want to change just by slicing up the string. So how does that help us to change the n at position 3 to a p? Well, what do? We take the first part of the string, which is place up to 3, which is the st space, and we concatenate that with the letter that I want, which in this case is a p. So I concatenate a p to that, which adds that to the string, and I concatenate on the end of that the end of the string, which is the eots. So I've taken bits of the string place from the beginning up to the letter, ignored the actual letter I want to swap and put the new one in there, and then from beyond that letter to the end, and I've assigned all of that back into the same variable place. So what's that actually done in memory? It's created a new variable, which is this concatenated one, and moved the label place to point at that. So again, we didn't actually alter the string sent neats, we just built ourselves a new string sent piets, and we moved the label place from the old string to the new string. And that's effectively how we do it in Python. So what we want to do is, in the vein of our Hangman program, build a function to do something similar. What we want to do is, given a particular letter, as we looked at in the previous example, at a given position, I want to put that into the string at that position. So I've been told, here's my initial guess, which is all those blank lines. I now know there's an A at position 2, so I need to put that into position 2. So what do? I basically take all the characters up to the position, and then ignore that one and put my A in, and then all the ones after the A, and I put that in. And obviously is where we build our string. Here's our string, and now I might find there's a C in here at position 3. So what would I do? I would take everything up to the A, and including the A, then I'd add a C in, and then I'd take whatever those 3 characters were and build myself a new string. So we need to be able to write that in Python as well. So let's just quickly code that. It's pretty straightforward. So def place character in, oh sorry, I should put some underscores in there. And what will this need to know? It will need to know the letter that I want to place. It'll need to know the position, and it will need to know, we haven't got it yet, but our guess, because that's what we're going to be building. We're going to be building up the guess as they add extra letters. So back up in our main program here, I'm just going to have to make my guess equal to, so I'm just going to use underscore spaces. So reality is 7 letters long, so 1, 2, 3, 4, 5, 6, 7. I'm just going to use underscore characters there. So what do I want to do within my function? Well, we know we've got our guess in here, so this is what we're going to alter. So our guess, oh, that was in the wrong part of my code there. My guess is going to equal So it's going to be guess from the start of the string up to that particular position. Remember, it's one less than that, so it will ignore that. We then want to add in our new letter, and then we want to add in our existing guess from one past the position, remember, because that's the way the indexing works, all the way to the end of the string, and we want it to return the guess. So let's see if that works. Now we obviously need to call our function from up in main. So place character in letter, letter is Y, pos, I've called it position up in main, so I'll call it position. And guess is guess, so it's going to do that. This, what's it going to do? It's going to return the guess, so I need to place that back into the variable guess, and then I should print it out. Guess is guess, apostrophe rather than a comma. There we go. So let's see if that program works. Invalid syntax, I've got my colon on my definition. There we go, so letter Y found at position 6, and the guess is, and you can see there it's put the Y, we assume that's at the end, and it's replaced the underscore that was there. If we just go and replace the E maybe at the start. There you go, E found at position 1, you can see it's put an E in at the start. Brilliant, so we've used our slicing here to good effect to slice up guess, get the letters before the letter we want to change, substitute in our new letter, and from the letter, beyond the letter to the end, build our new guess. So that's all working in the context of our Python program. So brilliant, that's basically what our Hangman function has done, and we've used string slicing to good effect. So that's it. Thanks very much. Bye.